So to avoid these problems, the textbook provides wrappers for read and write called robust I/O. And these variants are just like read and write, but they loop as needed to get or write as many bytes as you said it should send, unless an end of file is hit. So if an end of file is hit, then they'll return short counts. But otherwise, and that actually the end of file is only relevant for read, otherwise it'll keep going trying to get as many bytes or send as many bytes as you request. So our revised TCP server is going to work this way. It's going to go into a loop. It's going to read using RAO readIn, the capital version, which does error checking. When amount comes back as 0, that indicates an end of file, just like regular system read returns 0 for end of file. So in that case, when the server gets an end of file, then it knows the client is really done, and it can write back however much that it read. Otherwise, it's just going to write the amount that it got and then keep going, keeping a running total. On the client side, meanwhile, it will use RAO write-in. That will make sure, we used to have some error checking to make sure as many bytes as we wanted got sent. Now we can just leave that to RAO. The shutdown here is not a close because we still want to read back from the server, but shutdown sends an end of file. So this is the improved part of our protocol. If we then go try these out, so let's stop TCP server and run TCP server 2. And then we need to use client 2 because the server and client need to agree on the protocol. Now I send hello and it's 5,000. And even if I make it a bigger number, like 10,000, all 50,000 got sent. And that took just a little while, but all 500,000 hellos got sent there that time. So that's a great improvement, and this is a basically sound protocol to use over TCP. We could make our code even simpler by adjusting the protocol to not wait for an EOF, but have the client send at the very beginning how much data it intends to send. So with our last revision of the TCP server, it's going to read from the client how many bytes will be sent, and then it can just use RAO readIn to read exactly that many bytes. And then it can write back to the client, well, it can write it to standard out, and then write back to the client, that is how many bytes I read, and then close. So we don't need an EOF. That simplifies the client a little bit. It doesn't need to use shutdown instead of close, but it does need to compute how many bytes it's going to send and send that as the first thing. Right? And then the only bit of error checking that we really need is to make sure that when we get a response from the server, we do get it, that it's not truncated somehow. Just to demonstrate that last one, that it works basically the same. So from the outside server 3 and client 3, let's just send 1,000 hellos and we got 500. One other thing you'll see when you look at the code is that we are using the simplified version. So the server got much simpler by using open listenFD instead of the whole getter bind combination. Actually, this listen shouldn't be there. Even simpler. So I'll fix that. The same in server 3. Right, server 3 was already right without the redundant listen. And on the client side, we use open client FD to simplify things there.